Hello, welcome back. Today in this video content, we will see the different types of schema. So this concept is predominantly concept of a data warehouse, and you might have heard about these concepts or the terminologies. Basically, there are different types of data warehousing schemas, that is star schema, Snowflake, and Galaxy schema. So basically, let us understand in this video like what is a schema and what are the different types of schema and what are the different when to use which schema and when not to use which schema basically. And but by end of this video you should be able to identify and you should be able to design your own schema according to the requirement given. So that is the whole intent of this video. And before proceeding, if you are new to this channel and haven't yet subscribed for this channel, we would recommend you to please subscribe and also press bell button for instant notifications. So let's get started. Basically, if you are any of these fall any of in any of these categories, right? If you are a SQL developer, big data developer, data engineer, data warehouse or ETL developer, or mainly the data architect or data modeler, because if you're towards architecture or data modeler, so then this is most important for you to understand a big, because this will be the basic concept if you want to become a data architect or data modeler. And also if you are into a data reporting developer, data scientist, data or ETL tester, database admin, or just a data enthusiast to learn about data and different terminologies around the data. So we can call you are target, you are one of the target audience, and it is good to understand these concepts with some simple examples so that you will understand what are the different schemas that you can use and how the designing works, right? So with that, we will directly jump to the definition of understanding the schema, what exactly schema is. So schema, when we are talking about here, we are talking about the data warehousing concept. So schema, you might have heard about a data in data warehouse also there is a schema. So this schema what we are talking here. It's a conceptual schema what we are talking about, and it is mainly the data warehousing concept. So which is used to define the way the tables are organized. Basically, the tables can be organized in multiple ways, and there can be a relationship between different tables. So, if you are familiar with the RDBMS, where the relational database tables are actually linked with linked with each other using the primary key and foreign key relationship. Similarly, here also the tables are linked with primary key and foreign key relationships. However, this is more of a designing concept, right? Not the technical concept, like not the implementation, uh, like at a very implementation level. This is not a, this is very conceptual knowledge that we are discussing here when we are talking about data warehousing schema. And what happens here is there might be a multiple tables, and each tables will be associated with other tables. So this is very generic term. But however, in the data warehousing, you will have a fact table and dimension tables. So dimension table also called as a dim tables. So fact table and dim table, whatever we have, so you can do a different permutation and combination along with this, and you can the output of this different permutation and combination will lead to a different type of schema that we were discussing, like star, snowflake, and galaxy, that we will see in a few moments now. And basically the optimized and well designed blueprint. So basically why we need schema is so to design in a more optimized way, so that it will be like a blueprint for us which will give us the best performance possible for the given scenario, because each business scenario or each business use case are very different. Maybe you can consider the volume, maybe you can consider the complexity, right? Maybe you can consider the how the data is growing over the time, right? So considering all those things, you need to design, you need to choose carefully which schema need to be used, and so that schema that what we are using is basically looks like a blueprint. So with that blueprint, we will start our. So the last point, strictly enforce in past. What that means is basically if you take 10, 15 years back, the schema designing the schema or to start the project with a well-defined schema or the well-defined design was mandatory because of a couple of reasons. If you take in the current scenario, we have a good compute and storage resources nowadays. You can use I mean, you can upscale horizontally or vertically basically to increase your compute power and both storage power as well. Um, with that, actually, even though you are not following a strict schema or strict design of a schema, so you can still survive. But in the past, it was not the case because the resources was there was a resource constraints because you are using on-premise system and upscaling and downscaling was a challenge in that case. So it was actually must have in the previous, but nowadays it is good to have um, in the current scenario where you actually start with it's always a good practice to start with the designing a schema and choosing the which type of schema you need for your use case. So with that, actually, we can go to the types of data warehouse schemas. So basically, at a high level, we have three different schemas. First is star schema, second one is Snowflake schema, and third one is Galaxy schema. So basically, as I was telling in the previous slide, it is just the combination of fact tables and dimension table and how you organize them in a different possible ways will define which type of schema you will end up with. So we will take a couple of examples and understand in detail each one of these. So starting with star schema. Star schema is very straightforward and it is most commonly used, I would say. And it permits one central table. There will be one fact table which will be in the center of the design, and it will be associated with multiple dimension tables, right? Basically, we can call it as a one-to-many relationships. Basically, as you can see, uh, there will be one fact table at the center of the design, right? This is a fact table which is center of the design, and you can see there are multiple dimension tables around it. Okay, and the point here is to note is the fact table will be in the center and the dimension tables will be around the fact table. And other point is there cannot be any relationship between these two dimension tables. Okay, so like this like fact table the all the relations should actually pass through the fact tables only, and there cannot be relationship between say this date dimension and customer dimension or the store dimension with the date dimension. That is not possible here, right? And so that is how the simple star schema looks like. Okay, and one fact table around multiple dimension tables. Basically, linking dimension tables are denormalized to have more contextual data helpful for reporting and analysis. Basically, these are not like normalized. Basically, if you see date dimension table, store dimension, product dimension, customer dimension, these are not further split into subtables. That means these are not normalized. These are denormalized. That means these are kept, all the possible details is kept in this table, and there is no split, there is no normalization of these tables further. Okay, and enables good query response as table is denormalized because this is like the tables is not normalized here, the tables are denormalized. That means all the data related to date is stored in this table, all the data related to customer is stored in this table. However, same with product and store. So the query, actually, if you want to query this kind of a schema, how do you query is it is just joining invoice table with a date table and invoice table with a store table, right? And once you join, it is just with the invoice like a customer ID or date ID, call the you can join with the multiple dimension tables and create your query, right? It is just one join that you have to do here. So yeah, I mean basically this is most commonly used, we would say, right? And and if you see what are the cons, definitely there might be some cons on the star schema also, right? The star schema, the con is if the requirements are changing very frequently, then star schema, using star schema could be a problem, because what happens is as the requirement change keep on changing, since you are maintaining the table in a denormalized form, that means you are not split the tables into multiple chunks or the multiple child tables. What might happen is implementing those changes or the requirement changes would be a tedious task to do, and it might hamper the entire design. And other con is like a data redundancy, because your tables are denormalized, you might end up in creating a redundant data because your tables are not normalized. So if a table is normalized, basically you can store the data, I mean you can store this storage basically by avoiding the data redundancy. So in case of star schema, so there will be a more storage or the more data redundancy happening because of the tables are not normalized. That means the tables are denormalized. So further going to the Snowflake schema. So Snowflake schema I mean snowflaking process basically completely normalizes purposefully data to extreme possible. So what that means is, suppose I want to further normalize the tables, right? I can do that by doing this. So as you can see here, the invoice fact table is dependent on store dimension, and store dimension is split into again a child table, which is we can call it as a normalized table for a store dimension, which is a location dimension here. So location of this store is moved to the child table, that is normalized table. So basically we are normalizing as much as possible here. Okay. And similarly, if we talk about product dimension, it is further split into vendor dimension and department dimension. So based on the vendor ID and department ID, it is further normalized here. So by normalizing this, what the advantage is, you will you will have advantage of utilizing the space as much as possible, because there is no data redundancy happening here, because you have normalized the tables as much as possible. Okay, to the extreme. And flexible for any change or maintenance, because since they are like a normalized uh, into granular level here, so if there is any change, it makes very easy to implement. So if there is one more column to be added in the vendor table, you can just add it, or the vendor table can be further split into a child table or further normalized if the requirements are getting changed, and if it is getting complicated, you can keep on doing that. So basically, Snowflake doesn't have any limitation. It can grow into any level, but the main important point is the root, basically the center of that should be a fact table, and rest all the tables should be dimension tables. So if you see closely observe, Snowflake is nothing but this is the Snowflake, beautiful Snowflake design. There is one. However, if you see the splitting happening going forward, right? So there can be multiple split. So it can go to the next level and it can split here, and next level again it can split here. So it is basically like a snowflake, how the snowflake looks, and the center is always one. So that's why we call it as a snowflake schema. Hope this was useful. I mean, it was able to, we are able to understand this, right? And going further, let us understand the cons. Definitely, there are cons for Snowflake design, because you have to maintain a lot of tables here, because you are normalizing to a extreme level here. So there can be many child tables, and you have to maintain those tables, right? Operationalize when you are in operationalization, you do operationalization of these tables. You have to maintain those tables, and also the main problem is if you come back and see this design, right? So since there are a lot of child tables, if you want to know the details of the department, right? So you have to start with from the fact table and join with a product dimension table, and then again join that with a department table. So suppose if you want to create one report, So on top of this entire schema, so you will have to write a lot of joins, right? Because there are a lot of tables that is linked with each other. Okay, and so that actually obviously it will degrade the performance of your query, but and it will take a lot of compute, and it might be a performance intensive, and it might take a lot of time to execute. So finally, we will see what is Galaxy schema. So Galaxy schema is multiple fact tables, same dimension tables is linked to the same dimensional tables. The, looks like a collection of stars in a galaxy, right? So this is how it is, right? So basically, if you see in the galaxy, the stars are, I mean, spread across um, without any basically center location, right? In the previous, if you see star schema, what was happening is, or in the Snowflake schema, there was one center location or one fact table, and around that the dimension tables are created. But here it is not like that. There might be multiple fact tables. The important point here is there can be multiple fact tables which are surrounded by the same dimension tables. As you can see, these two fact tables are surrounded by same dimension tables, right? So that's how these are linked. Okay, and this web actually it looks like a web, right? And this web can grow to any extent. Now I'm taking two fact table. You can imagine it can grow to go till like eight fact table, 10 fact table, and it can create a big mesh kind of architecture here, or big mesh kind of a mesh kind of a design. So for this is actually typically used where the requirements are too complicated, and which are not supported or which are not possibly supported if you are using star schema or snowflake schema. So then obviously you have to go for galaxy schema, but this needs very experienced knowledge about data modeling, because you need to understand the data very much, and which table to normalize, which table to denormalize, and how to create a relationship between multiple tables. So there is a lot of things to understand here, and it is too complicated design uh, for designing also, and also to implement it, and after implementing, so for operationalizing it also, it is too complicated to maintain it, and further if you want to query it also, it takes a lot of time. That's where we see in the cons here, there might be too many tables, and the maintenance will be a problem, and the because of the query complexity, right? Because as you can see here, if you want to write a query again, you will have to create a lot of join, compared to if you compare with this with a Snowflake design as well. So more than Snowflake design, the complexity of query will be increased in the Galaxy schema, because in Snowflake at least you have one fact table. Here you have multiple fact table, right? So obviously the query complexity will increase, and very bad query performance, because again lot of joins and lot of linking that you have to do when you are writing a queries. Finally, we will. So in this summary, as you can see, Uh, like basically, I have noted a few of the points. It is actually very important to understand this summary, because this is based on a certain example or a certain experience, right? And basically, if you are starting any new project, right, it is best to start with a star schema. The reason is star schema is a simple to understand, and simple to start with, and simple to implement it. Because if when you're starting a project, if you start designing, say Snowflake design, or you start designing star schema, I mean uh, the Galaxy schema. So what will happen is you will make the requirements too complicated. Yeah, there might be few use cases where it demands to start with Snowflake or Galaxy, but it is always good practice to avoid uh, start using Snowflake or Galaxy schema. So the thumb of rule is, yeah, use start with star schema, and as the requirement evolve, you can shift to Snowflake, and if the still requirement evolves, you can then further move to Galaxy schema. So that's how you should actually evolve over the period of time with respect to designing. That is the first thumb of rule. And the second one is for simple projects, just choose star schema. So don't complicate the requirement. If the project requirement is simple, so just don't complicate the design. So just use star schema, so that you are actually not complicating the design, not complicating the implementation, operations, everything, right? And this actually the entire game of choosing the schema is basically a trade-off between compute and storage. So when you say trade-off, you will have to play between the compute and storage here. So when I say compute and storage, what that means is you have to choose whether you want a better performance or you want a lot of storage, I mean good storage, I mean optimized storage. So let's take an example, right? If you are choosing a star schema, it is actually good for compute because you are not denormalize. I mean, you are not normalizing the tables. You are storing in a denormalized format. So that is the reason what happens is you actually it's good for compute, but however it is bad for storage because you are not splitting the tables. That is the reason you are actually uh, you are doing a data redundancy. So you are making a lot of redundancy because the tables are not normalized. And if you move towards the next level, right, Snowflake or Galaxy schema, what will happen is you are actually moving towards good storage and maintenance, but bad for compute, right? Because as you optimize or as you move towards Snowflake or Galaxy, what you are actually doing is you are normalizing the tables as much as possible. So as you go on normalizing the tables, what will happens is you are actually reducing the redundancy. That means you are actually saving towards the storage. But however, what happens is since the table is distributed, tables are distributed across different tables. I mean the data is distributed across different tables, spread across different tables. So you will end up to have a bad compute. So this is actually a better understanding when you should actually have that is it is a trade-off between compute and storage. So hope this was useful and keep this in mind about this summary what we discussed, and also go through this video if you are not understanding the concept again with the examples. And if you still have any doubts, please comment in the comment box. I'll try to take a different example and explain you as much as possible. With that, hope this entire video was useful and beneficial for you.